Hey everyone, I am Ranshakwa and welcome back to my YouTube channel. Today we will be solving today's Leetcode daily challenge, which is find the student that will replace the chalk. So let's see what is this question and how we can solve it. So there are n students in a class numbered from 0 to n minus 1. The teacher will give each student a problem starting with the student number 0, then the student number 1, and so on until the teacher reaches the student number n minus 1. Okay. After that, the teacher will restart the process starting with the student number 0 again. Okay. You are given 0 index integer array chalk and an integer k. There are initially k pieces of chalk. Okay. When the student number I is given a problem to solve, they will use chalk I, pieces of chalk, to solve that problem. Okay. However, if the current number of chalk pieces is strictly less than chalk I, then the student number I will be asked to replace the chalk. Okay. Return the index of the student that will replace the chalk pieces. Okay. So let's see what is this question. So in this question, we have been given within chalk array and the total number of chalks. And the teacher will start asking the questions from the student number 0, and then we keep on asking till the student number of n minus 1. And let's say if chalk of I is equals chalk of 0 is equals to 5, then the student 0 will use 5 pieces of chalk from this k pieces. And if chalk I is less than k, then that student will be asked to replace this chalk, right? So let's see. So in this example, we have been given with 5, 1, 5 and k is equals to 22, right? So this is the indexing. So this student will use 5 pieces of chalk, this student will use 1 piece, and then this student will again use 5 pieces of chalk. So let's see. We just need to find which student will be asked to replace the chalk, right? So see, we just start iterating this array, and then this student have used 5 chalks. Okay, so we will simply check whether k is less than 5. No, we don't think so. So we will just reduce k by 5, which will become 17, right? And then we will check for next. Does 1 is 1 is less than 17? No, then we will simply reduce 17 by 1, so it will become 16. Then we will check for next student. Is 5 is less than 16? No, then we will simply decrease it by 5. Okay, now we have come to the end. Then again teacher will start asking questions from the 0th student. Okay, now again 0th student will use 5 pieces of chalk. So we still have enough number of chalks, so it will again decrease by 5. Okay, now let's check for another student. Again we have enough number of chalks, so again it will decrease by 1. Now again check for another student. Again we have 5 chalks and this student requires 5 chalks only, so again it will get reduced by 0. Now again we have came to the end of the array. Now again the teacher will start asking questions from the student number 0. Now student 0 requires 5 pieces of chalks, which is greater than k, which is greater than the available chalks. So student 0 will be asked to replace the chalks. So in this question our answer will be 0, right? So see, here answer is 0. So what we have done is we have done just a simple iteration of this student array and checking whether available chalks are greater than or not to the required chalks. If yes, then just reduce the available chalks by the required chalks and then keep on checking for the next students, right? So we can simply write its code also. Let's see. So what we have done is we are just iterating this array till this size, right? And we will check if chalk of I is greater than the k, right? If we require more number of chalks than the available chalks, then obviously that student will be asked to replace the chalks, right? Otherwise, what we will do? We will just keep on decrementing the k by chalk of I, right? But see, here we have just done one iteration. What we are doing iterations stay when we have not encountered this situation, right? So what we can just do is we can just apply a while true loop here. So whenever this condition becomes true, we will exit out of this loop, right? But see, let's here the time constant in this question is n is equals to 10 की power 5. Okay, so let's discuss its time complexity now. So see here how many times we are iterating. So it is n, right? We need to calculate the time complexity for this while loop. How many times is we are executing this while loop? Okay, or we can say how many times we are executing this for loop content inside this while loop. Okay, so see in one iteration how many chalks are getting exhausted? I can say sum of chalk I, right? In one iteration we are exhausting the total number of chalks, right? Sorry, sum of the chalks, right? Sum of one iteration of the chalk in one iteration, right? Okay, and how many iterations total, how many iteration we need to do? Like we have total k chalks, and in one iteration we are exhausting or we are using sum of chalks. So total how many iterations we need to do to exhaust all the chalks? K by sum, right? So this while loop will be executed k by sum time. So the overall time complexity of this loop will become n into k by sum times, right? So it might be bigger in this context, like as we have given n is equals to 10 की power 5. So can we do it in less time complexity, like big O of n? So let's see if yes. So let's take the another example now. Chalk 3, 4, 1, 2 and then k is equals to 25. So let's see, can we do it in big O of 1, sorry big O of n. 3, 4, 1, 2 and k is equals to 25. Okay, so let's start iterating this array once. So in one iteration how many chalks we are using? 3 plus 4 plus 1 plus 2, 7 plus 3, 10. Okay, so which is less than 25? So yeah, we can easily do one iteration. Now let's do another iteration. So yes, we still have 15 chalks, so we can easily do another complete iteration as well, right? Now after this iteration we will be left with 5 chalks, right? So let's start doing the third iteration now. So we still have 5 chalks, so we can do still this student can solve the question. Okay, now we have left with 2 chalks. Now this student, yeah, it means now the student 1 will be asked to replace the chalks, right? See, here answer is also student 1. Okay, so see here we are given with total number of chalks, and as in one iteration we will be using the sum of the chalks. So we can simply get in which iteration we will be getting the student who will be asked to replace the chalks. How? By dividing the k by sum, right? So this is, let's say this is the 0th iteration, this is the first and this is the second. So in the second iteration we will be getting the person who will be asked to replace the chalks, and by during this iteration can we know how many chalks will be left? Yes, like simply by this 25 modulo 10, because 20 chalks will already be used in the upper 2 iterations, right? So in this iteration how many chalks will be remaining? 5. Okay, now we know this, that in this iteration only we will be getting the student who will be asked to change the chalk, and we also know that how many chalks are remaining during this iteration. So is it not sounding like only single iteration? Because in this iteration only we need to compare the chalks with this number, because in this during this iteration these number of chalks will be available. Okay, now this question becomes very simple. What we just need to do, we just need to find the sum of all the chalks, and then we need to modulo the total number of chalks by sum, so that we can get the total number of remaining chalks for the last iteration, so that we can find that which student will be asked to replace the chalk. Okay, so let's see how we can code this. So what we need to do is we can just store the size of the chalk array, and then we can store the sum of all the elements of the chalk. Why I have created sum as long, because chalk I can be big up to 10 ki power 5, so it can be a greater sum, so that's why I have declared it as long. So first we just need to find the sum of the complete array. Sum plus is equals to chalk of I. Okay, and what we need to do is we need to find the remaining chalk for that iteration, in which we will be getting the student who will be asked to replace the chalk. How we can get that? K modulo sum, right? And then in this and then we just need to do one iteration to find that student. How? If remaining chalk is greater than or equals to chalk of I, right? Then what we need to do is we just need to do remaining of chalk minus is equals to chalk of I, right? If it is less than, then we will just simply return that student, right? Otherwise, and we can just return -1 by the end of this loop. Let's try run this. What I have done here is, so why it is giving me output as 0. Okay, we can't just return it, we just need to insert else also, otherwise after executing this loop it will return I, so we just need to insert return as well. So let's try submitting it. Yeah, it's working fine. So let's discuss its time and space complexity now. So as we just need to iterate the loop once this and then once this, so they are just simple iterations, so we can say its time complexity become big O of 2 into n, because we are iterating the loop twice, or I can say big O of n. And as we have not used any extra space, so its space complexity will become big O of n. Okay, so yeah, that's all for this question. If you have any doubts, then you can post in the comment section. I will surely try to answer them. Bye guys, see you in the next video. Till then, keep learning and stay curious.